When you update or delete data in PostgreSQL, the database engine doesn't actually erase the old information. It leaves those original records exactly where they were on the disk. This happens because of how the system handles multiple users. If one person is reading a file, a second person can't overwrite that same file without locking the first person out of the system. To keep things moving, PostgreSQL uses multi-version concurrency control. When data changes, the system inserts a new document version. The older version is crossed out but stays in the folder. This allows one user to safely read the old draft, while a second user writes a new version. Because two copies exist, readers never wait for writers. While this approach makes the database fast and responsive for high-traffic apps, it also creates a physical buildup of old data that eventually needs to be cleared away. These crossed-out obsolete records are known as dead tuples. Once every active transaction is finished with an old version, that data serves no remaining purpose for the database. In a busy system, this buildup happens fast. High-traffic databases can generate millions of these dead tuples every day, quickly filling up the storage folders. This leads to table bloat. The physical files grow larger, filled with unusable dead records, taking up valuable room. This bloat drains performance. Every time you run a query, the database has to spend time and processing power scanning past all that dead trash just to find the active information you actually need. Without a way to intervene, the very system that makes the database fast eventually causes it to grind to a halt under the weight of its own history. To handle the cleanup, PostgreSQL uses a built-in process, aptly named Vacuum. Vacuum scans tables for dead tuples and clears them out, leaving empty gaps. A standard vacuum doesn't shrink the physical database file on your hard drive. The cabinet stays the same size, but those internal gaps now glow, ready for use. The system maps out these empty spaces, so new data can be slotted directly into them. This allows the database to reuse its existing footprint, instead of constantly growing larger. Standard vacuum keeps the internal space organized, ensuring you can keep adding data without buying a bigger physical storage drive every month. Running this cleanup manually is nearly impossible for modern 24/7 applications. It would require a human to watch the database every minute of every day. Instead, Postgres relies on AutoVacuum. It's an automated janitor that runs quietly in the background without a human trigger. The process is triggered by a simple gauge. When the volume of dead data in a table crosses a set threshold, the background janitor automatically wakes up, cleans the table, and resets the gauge to 0. You can tune this automated worker to use very little memory and run at specific speeds. This ensures it cleans the database effectively without slowing down your main application traffic. This turns a complex manual chore into a reliable cycle that keeps the database healthy automatically. Some administrators are tempted to turn AutoVacuum off to save on CPU power. In the long run, this choice is almost always a disaster for the data. This is because of the transaction counter. Postgres assigns a unique number to every change, but the counter can only go up to 2 billion before it runs out of numbers. If that counter hits 2 billion and rolls back to 0, all your old data suddenly appears to be in the future. When this happens, the database can no longer see your existing records, effectively making your entire database invisible and unusable. To prevent this, AutoVacuum performs a task called freezing. It stamps very old data as permanent, which allows the transaction counter to safely restart without the database losing track of the past. Regularly freezing these old records keeps the transaction counter away from that 0-point limit, ensuring the database remains online and reachable for years to come. The difference is clear. A neglected database eventually chokes on its own buildup, while a well-vacuumed one remains fast and predictable. Leftover data versions are the trade-off for speed. They are the price of a system that allows thousands of people to work at the same time without waiting in line. AutoVacuum manages the physical reality of the hard disk, making sure that this high-speed architecture doesn't overwhelm the system's storage. To keep your data healthy, tune your workers, follow the stats, and let the background janitor do its job. That is the essential work of PostgreSQL.